All right, good afternoon, everyone. Thank you so much for having us here today. As you noticed, we work for the Yukon River Intertribal Watershed Council in Whitehorse, Yukon, and today we're going to talk about the community-based monitoring of the active layer in the Yukon River watershed. But first off, I would like to thank the event organizers for the invitation to present to you all here today, and to Yukon Government Climate Change Secretariat for the travel support. And I would also like to recognize the Yellowknives Dene First Nation. I'm also a Dene person, so thank you. And I'll pass it over to Brendan, and he'll talk a little bit more about it.
Thank you, Jody. So this afternoon, Jody and I are going to be speaking to you a little bit about our organization. I'll start by introducing the area in which we work, the Yukon River Watershed, give you a brief history of our organization, and a quick overview of two of our flagship projects. The first one is about monitoring surface water quality, and the second is what we'll be focusing on. That's about monitoring permafrost through what we call our active layer network. Jody will explain the methodology of that project. We'll quickly glance at some of the results just to give you a flavor of what they look like and talk about the lessons we've learned. So the Yukon River watershed, it's the fourth largest drainage basin in North America. The main stem of the Yukon is well over 3,000 kilometers in length. The watershed's home to about 130,000 people, many of whom continue to maintain a subsistence lifestyle. There are a number of Aboriginal cultures represented in the watershed, from Yupik, Kayakan, Athabaskan, Tlingit, and others, comprising 75 distinct Aboriginal governments. The area is also home to 20 ecoregions, from the Yukon's southern lakes down to Alaska's subarctic coastal plains, making it one of the largest and most diverse ecosystems on the continent. And the Yukon has 8 major tributaries. 2 of those, the Tanana and White Rivers, provide about a third of the flow to the main stem, and they're generally underlain by discontinuous permafrost. The Porcupine and Kayakuk rivers provide about another fifth of the flow, and they're generally underlain by continuous permafrost. So briefly about our organization, we were formed in 1997 by a group of Indigenous leaders who got together and decided to create an organization with the longest name possible. No, I'm just kidding. An organization aiming to preserve and protect the Yukon River watershed. So we have 70 signatory First Nations and tribes across Yukon and Alaska. They are represented by 14 executive committee members, 7 on the Yukon side and 7 on the Alaskan side. We are currently co-chaired by Carl Sidney, Chief of Tesla and Tlingit Council in Yukon, and Clarence Alexander from Fort Yukon, Alaska. Our organization has 4 departments. We have offices in Fairbanks and Anchorage, Alaska, and one in Whitehorse that Jody and I are representing. We have a solid waste department, a sustainable lands department, an energy department, and a science department that we both work for. So 2 of the big projects of our science department we call ION and ALN. So ION is our Indigenous Observation Network, that's water quality monitoring, and ALN is our active layer network, which monitors that active layer that we've been discussing throughout today, that layer of soil above the permafrost that freezes and thaws annually. So briefly about our surface water quality program, we collect samples biweekly from open water in a number of sites around the watershed. We've been working together with 26 of our signatory communities in the past decade or so, and we've sampled over 50 sites in that time period. The number of samples we've collected has increased from about 30 when we started in 2001 to well over 200 this past season. And the reason why I wanted to touch on this project is because, as Steve Coquel noted this morning, and others have touched on, one of the major drivers of changing water quality that we're observing is permafrost degradation. So that brings us to the project we're going to describe in a little more detail, what we call ALN. So here's a map of the Yukon River Basin, which you can see crossing the border between Yukon and Alaska. We have 20 sites in the watershed as part of this network. In 2009, a dozen sites were installed and another 8 were added the following year. 17 of those sites are in Alaska, so we only have 3 in Yukon. The sites were selected to have a presence of permafrost within approximately 1 meter of ground surface. and that was, they were located based on local traditional knowledge and some ground truthing. We wanted to have the sites roughly distributed evenly throughout the watershed and located near communities where we have good relationships and the communities are dedicated to doing the monitoring work, and it's feasible for us to travel and visit the sites regularly. So to talk more specifically about what we do at each site, I'll ask Jody, who has a number of field seasons of experience here, to take the mic.
Thanks, Brendan. Okay, so methodologies. What do we do at each site? All right, so Brendan had mentioned that we have 20 ALN sites throughout the watershed. And usually we visit these sites at peak thaw, end of August, early September. And it's one day of field work. And the first thing that we usually do is do the manual measurements. So we have a 50 meter by 50 meter grid with the corners staked, and we conduct 100 measurements within this grid. And this field sheet kind of represents the grid of our ALN sites. The corners, we write down the coordinates of each corner, and then for the X's that are circled, that indicates that there's a stake. If there isn't a stake, we'll pace out 5 meters or use a measuring tape. And it also states that we have around 10,000 individual measurements over the 5 field seasons. So this is a youth from Tesin Council that we had worked with this past summer. We have sensors in the middle of our grids. So there's an air temperature sensor tacked to a tree with some tin foil on it for protection. And then our hobo data loggers that we have 4 sensors attached to this data logger. So we have 2 temperature sensors and 2 moisture sensors in the ground. So 2 are above the permafrost and the other 2 are just below the surface. So the other part is downloading our data. So when we come, we'll make a visual inspection of our sensors to make sure that everything is running correctly. If it's not, then we'll change batteries or replace any of the equipment that has been damaged. And one of the main problems, I guess, that we've been having is water damage or animals chewing on our equipment. I think we had somebody actually shoot at our equipment in Lower River or driving it over the top of it with the ATV. Oh, and one other thing I wanted to mention so it's every 30 minutes that we're collecting this data. So this year we had collected soil samples outside of our grid. We don't want to disturb our grid. For soil, to calibrate our soil mesh sensors. And we collected soil samples just below the surface and then above the permafrost. And with all of our projects at the Watershed Council, we work with our community members. And we also have a partnership with the United States Geological Survey. We had Nicole Herman Mercer from Boulder, Colorado come up to Alaska to talk with youth. And so this year we had about 30 community members work with us this past summer. And from that, I think I'll pass it back to Brendan.
Thank you, Jody. So I know we don't have a tremendous amount of time this afternoon, but we wanted to give you a quick glimpse of what our data look like, just to give you a flavor of that, and because we're hoping to develop new partnerships to be able to interpret and analyze that data and then disseminate results to our signatory First Nations and tribes. This is just an example of a year's worth of air temperature sensor readings at our Dawson, Yukon site. So this was the first year of monitoring from 2009 to 2010. As Jody mentioned, we visit when the active layer is at its thickest or the permafrost at its deepest, usually in late August or early September. So our year goes from that time until the end of the subsequent August. And you can see at this location, we have freezing temperatures from between approximately October to April. This next image shows our results from the soil moisture and temperature sensors. And as Jody mentioned, we have two of those, one just below the ground surface and one just above the top of permafrost. The shallow sensors readings are depicted in red here and the deeper ones in blue. And we can see some differences, some important differences there, and some correspondence with the air temperature readings that dictate the temperature regime in the area. And again, we're not going to get into detail here, but I just wanted to show you the type of data we have. These are readings made every 30 minutes over the course of the year, and we have this for 5 years at most of our locations. Not to mention a mountain of field sheets that Jody showed you an example of our manual measurements made at each of our grid sites. So we're generating a tremendous amount of information. But our greatest result, we think, is that we have communities leading the way. So as Jody mentioned, we had over 30 community members leading the way in the field this past season. And some of them have been working with us for a number of years and are ready to take over these sites. Others are newer and are still receiving some training, but we're really proud to be working with such a great network of people that are so enthused and so capable. So briefly to wrap up, where do we go from here? What have we learned from our efforts? And I think the first point to make is that community-based monitoring really does work. The community members we work with are really interested, they're highly motivated, and they're very good at the field work they do. A lot of these field techniques, as many of you know, don't necessarily require a PhD to do. They could be some simple things that local people are very, very good at and interested in doing. We have a number of communities wanting to join the network. We're working on pursuing some funding to add some new sites. Each site costs around $2,500 to equip and install. We're working towards handing off sites to our partners over time. We really want to work on the sustainability of this network through the eventual handover to our signatory First Nations and tribes. What we need to really work on, though, as an organization, is disseminating our results. So we've been collecting this data for 5 years now. We've generated a vast amount of information. I think we've done a great job at building the capacity of our partners to participate in the network, but we need to analyze and interpret our data, and so this is a big motivation for us to participate today and reach out to all of you. I know there's a ton of expertise in this room, so if you're interested in working together, your assistance is very welcome, and please feel welcome to approach Jody and I in the coming days. And thanks again for the opportunity to speak. So our email addresses are on this slide if you want to scribble those down, but otherwise we're available and really keen to meet and speak with you all throughout the week. So thank you very much.
Thank you, Brendan and Jody. We have time for questions if people have any. I'd ask you to go up to the mics again and identify yourself before you speak. While people are thinking about questions, I have one. One of the challenges that I've seen in community-based monitoring is securing sustainable funding. I wonder if you could talk about how you've handled that particular challenge.
Well, that's a very good question, and I mean, it's a challenge that's ongoing for us. One of the ways that we've been fueling this work the last few seasons has been to couple the site visits with other projects we have ongoing. So when we're going to take water quality samples or do training related to other projects, we take the opportunity to visit these sites, inspect them, and take out community members. So this past year, actually, the field work that Jody and I did not have any distinct funding, but was piggybacked on other work. But it's a challenge that's ongoing for us, and I think really the best prospect we have is for our partners to take over the sites and assimilate the work into their work plans for their environmental technicians.
All right. One final question, I guess. You mentioned that the next stage is disseminating the information you're gathering, the data you're gathering. Have you been able to provide information to the regulatory boards, the Environmental Assessment Board, Land Use Planning Boards to this date? Or is it still early days yet?
I would say it's still pretty early days. We have a lot of data that we need to look at ourselves and then bring it back to our First Nations and then kind of get their direction to see what they want to do. But yeah, we're still at early stages, I would say. I don't know if you want to add to that, Brendan. Yeah.
All right, thank you. Any questions? Any web questions? No? All right, well, thank you very much for the presentation.